What's up, team? Today we are talking function notation. Let's dive right into this. So the use of functions, or the use of function notation is simply a different way to read functions. We're using them the same way, but we're just reading them differently. So this notation provides us with a more efficient way to talk about the functions. Now, when you see this function notation, people start to get a little bit worried. You might see some of the stuff right above me here in the reminders, and you're like, oh, wait, what is happening? What is this? I want you to be confident in the fact that there's no new math concepts going on today. There's nothing new math-wise. You're not going to have to learn how to calculate something in a new way. We're using two concepts that we're already familiar with, that we've already used a ton of times. We're going to be using substitution, and we're going to be using PEMDAS. These are things that at this point in time you should be very comfortable using. So it's just going to be a different way to look at the types of functions, but the only math we're doing, substitution and PEMDAS. Functions are generally used to find the output, which is the y value, for some specific input. And that's all we're going to be doing today. We aren't going to be doing anything too wild and crazy, not too out there. We're just going to be finding some output for some input with a given function. Okay, let's do an example here. And this is not function notation. I want to make that very clear. This one that we're doing is not function notation, but we have to do it to provide a little context. And I think it's going to feel pretty familiar once we start getting into this. So say we have some function, y equals 2x plus 5. There's no rhyme or reason, like this isn't any sort of special function, it's just a random one that I picked. So don't look into it too much, but this is the function we are going to use for our example today. Our mission with this function, we are told that we are to find the outputs when the inputs are 1, 5, and 10. So now we need to put our thinking caps on a little bit and remember which variable is our input, which ones are our outputs. So if you remember, the x values are the inputs and the y is our outputs. So if the inputs are 1, 5, and 10, all we need to do to find the outputs for this given function is just to do some substitution and PEMDAS as promised. So we're going to plug this 1 in for x, or substitute this 1 in for x, and that'll give us that particular output. And then, whole new problem, substitute the 5 in for x. Find out the output. And then, whole new problem, plug in the 10 for x and solve. And so we're going to get 3 different solutions. So let's see how this looks. So when x equals 1, what we're going to have here is y equals 2, and it was 2x, but now it's going to be 2 times 1 because we're doing that substitution, plus 5. And so we quickly see here, we know 2 times 1 is 1, 1 plus 5 is 7. So we learned that when the input is 1, the output is going to be 7. Cool, not so bad. Let's keep going with this. So now let's look at when x equals 5. And we're going to do the same sort of thing. Y equals 2 times 5 plus 5. 2 times 5, of course, is 10. 10 plus 5 is 15 here. So I'm because of space, I'm going to move over to the right here and say y equals 15. This is our output when this is our input. So if you plug 5 into this function, the only possible output is going to be 15. Let's do one more. We're going to do it when x equals 10. And it's the same exact process. So y equals 2 times 10 now plus 5. Again, this function, the 2x plus 5, you can see it all the way through here. 2x plus 5, 2x plus 5, 2x plus 5, same function over and over, but we're substituting the values that we're asked to substitute in so we can find the correct outputs. 2 times 10 is 20, 20 plus 5 is 25, so y equals 25 in this case. Again, this is not function notation, but hopefully you're able to see this and be like, oh, yeah, I get that. I see what's going on there. And we're going to build on this a little bit with function notation. And really, like I said, we're just going to try to find a way, or I'm going to show you a way, to write this type of problem down a little bit more efficiently. Okay, now we're in function notation. This looks different. I get it. Let's talk about this. What's going on here? What's different about this function, or the notation for this function, and the notation from the one just a moment ago? The one a moment ago said y equals 2x plus 5. This one, well, it has this f in parentheses x. What is happening? F times x. What? First of all, it's not f times x. Don't ever think about this as f times x. You see that in the reminder right above me here. The way that we read this using our words is we say f of x, meaning that there's a function in terms of x. And this is the function in terms of x. So if we find that x value, we can then figure out what the outputs are for that given x value, that given input. So this is what we call function notation. If you see f of x like this, function notation. And the value of this is, if you remember a moment ago, we were trying to find the outputs when the inputs were 1, 5, and 10. So we're going to do the same exact thing, but now we're looking at it in function notation. So instead of writing out that kind of like lengthy, wordy sentence, we can simply say find f of 1, f of, not 2, we're not looking for 2. We could find 2, but that's not what we're asked to do. F of 5 and f of 10. And that's how we would say this, f of 1, f of 2, f of 10. Now, you're probably still thinking, wait, what is even happening here? What are you writing? Parentheses, why the f's? You're in an okay place, so that's what you're thinking right now. Because I'm going to show you how this works. So just like how f of x is kind of our generic y value here that we're using, or this value instead of y, when we replace the x with 1, when we go from f of x to f of 1, all we're doing is replacing the x with a 1, because that's our new input. So when we replace the x with 1, we're also going to replace the x with 1 for the rest of the function. We're just doing some substitution. So for example here, actually I'm going to write the whole thing out again. I'm going to write the original function, 2x plus 5. And then I'm going to write my f of 1. And because I substituted x in for 1 here, I now have 2, and now I'm substituting 1 in for x here as well. So we'd say that f of 1 is 2 times 1 plus 5, or we'd say that f of 1, after doing PEMDAS, we'd say f of 1 is 7. Okay, let's look at f of 5 now. Now this is the same sort of thing, but instead of plugging in 1, we're going to plug in 5. So we'd say 2 times 5 plus 5, and then we learn that f of 5 equals, let's do the math here, 2 times 5 is 10, 10 plus 5 is 15. So f of 5 is 15. Lastly, we have f of 10. So 2 times 10 plus 5, we learn that f of 10 equals 25. And here are our solutions, and this is how we would talk about those solutions. We'd say, if we're given this function, f of x equals 2x plus 5, then we know that f of 1 is 7, f of 5 equals 15, f of 10 equals 25. So this notation, this is, the f of x is the new notation. That's the new stuff. You're not really doing any new math with it, though, because all that's happening is instead of writing y, you're writing f of x. Hopefully that's not too crazy. You're just calling it something else. It's a new notation, a new name for the y value. And then it gets kind of funky because then we start putting numbers in here, but that's just substitution. That's all we're doing is substitution. So if you're asked to find f of 1, well, then plug in 1 for x in the f of x, and then plug in 1 for x anywhere else you see in x, and then do PEMDAS and reach your conclusion. So in terms of inputs and outputs of this function, when 1 is the input, 7 is the output. When 5 is the input, 15 is the output. When 10 is the input, 25 is the output. There's no special value to any of these numbers. I just picked 1, 5, and 10 randomly. You can pick any number ever. 2, 10, 100, a million, pi, 18 pi, negative 32,006. Like whatever, any number you can plug in. F of blah. You would just put it in this sort of notation, f of blah. And then when you're substituting things in, 2 times blah plus 5 equals whatever it ends up equaling after you PEMDAS it. Okay, this is function notation in a real quick nutshell. Go ahead, work on some of the examples. Let me know if you have some more questions, but I believe in you. I think you got this.